In this example, we have a word problem that will lead us to a system of equations that we'll solve using substitution. All right, so let's read this problem. Biologists studied the weight of two alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown in the table below. Write a system of equations that biologists could use to compare the weights of the alligators. And I believe we may have used this example before. All right, so alligator 1, its initial weight, its starting weight is 4 pounds, and it gains 1.5 pounds per month. And alligator 2 weighs 6 pounds, and it gains 1 pound per month. And I'm going to slide this piece of paper down, and let's see what I've got below. I believe I set up both of these equations, and let's see what this looks like. All right, I'm going to use a table here and slide this over and see if this all makes sense. For my first equation, I've got for alligator 1, I said let W equal the alligator weight, and let T equal the time in months. Therefore, the weight of this alligator is going to be its initial weight plus its growth rate multiplied by time. In other words, what was its weight when we started the experiment, and how much does it grow for every given unit of time, in this case, months, all right, because T is time in months. So its initial weight was 4 pounds, and to that we have to add its growth rate of 1.5 pounds per month. Therefore, W, the weight of the alligator, equals 4, where we started, plus the 1.5 pounds per month that it's growing. All right, for the second alligator, same equation. W equals the alligator weight, really the initial weight, the overall weight, and T equals time in months. So the weight of this alligator is going to equal its initial weight, where it starts from, which is 6 pounds, plus its growth rate, and it's growing at 1 pound per month. T represents time in months. All right. That means for this second alligator, we have the equation W equals 6 plus 1T. In other words, we have two equations for this system. I'm just going to slide this up slightly so we can see them both. We have this equation, and we have this equation. And now I'm going to pause for a minute, and I'm going to take these two equations, and we're going to set up a system, and we're going to solve it. All right, here are the two equations that we had for the weight of an alligator. And as you can see, it looks a little bit different than the other systems we were looking at. So let's make sure we understand this. In both of them, W is on the left side. So W equals two things. It equals 4 plus 1.5T, and W also equals 6 plus 1T. In other words, I can rewrite this like this. 4 plus 1.5T equals 6 plus 1T. All right, why can I do that? Well, because W equals both of these things. In other words, these two things are equal. When I say things, I should be saying these equations are equal. We know that if W equals this and W equals this, then these W's must be the same. They're the same variable. And that allows me to do this. That allows me to write an equation on either side of the equal sign, and now we have to solve this by combining like terms. Once again, we're revisiting rules of equations that we learned earlier. All right, so remember, if W equals 4 plus 1.5T, and if W equals 6 plus 1T, then 6 plus 1T and 4 plus 1.5T have to equal each other. And they do. All right, let's solve this. I'm going to solve this by subtracting 4 from both sides. That's my first step. That's going to leave me with 1.5T equals 2 plus 1T. And now I am going to subtract 1T from both sides. And I'm going to actually write it as 1.0T. This way I can keep my cells nicely aligned, which means I've got 0.5. Actually, it's probably better to write the number first and then put in your decimal point. That, of course, equals 2. And now I have to isolate T by dividing both sides by 0.5. let's see, there you go, write the number first, and then put in your decimal point. All right, I'm going to divide both sides by 0.5, and t equals, well, 0.5 is the same as 1/2. How many halves fit into 2? 2 halves fit into 1, therefore 4 halves fit into 2. T equals 4, and that's half of our system. So now let's solve our other half. Let's figure out what W is. And I'm going to pick this equation to substitute in because I think it's simpler to work. So W equals 6 plus 1t, and t, of course, as we already solved, equals 4. In other words, W equals 6 plus 1 multiplied by 4. W equals 6 plus 4, and W, of course, equals 10. All right, the solution for this system would be 4, 10. And that would be the point in time where the alligators would be the same weight at this point on the graph. All right.